Hi, good day to you and welcome to my channel that I tutor you in science for free. The topic in this video will be forces. And forces stands for the effort that is used to create certain effects from one object to another in the form of push or pull, like pushing a door open or pulling a luggage. So here are some examples of various forces: contact forces and non-contact forces. Under contact forces, there is the normal reaction. Normal reaction does not mean if it is not normal means it's abnormal. No, it's more of the mathematical term for normal. Like if a ball is in contact to the ground, then the point that matches the center of the circle is called normal, something like that. So it does not have the normal versus abnormal kind of feeling. This is a more of a mathematical notation. So if you place something on the table and there's a downward force called the weight of the object down on the table also exerts a certain amount of force upwards so that it stays in position. And of course, every table has a certain X amount of weight before it crumbles. If probably an elephant stands on a classroom table, the table is going to collapse. So the table is not able to exert that amount of normal reaction. Okay, so that is normal reaction. Friction, very common on footwear, on wheels. Friction is the force that opposes between surfaces in contact. Tension is generated by a pull on a string, and if you need to draw the arrow in the exercise, you have to draw it on the string itself, not in the air or anywhere else. It must be on the string or on the rope. So next we go on to non-contact force. We have gravitational force, we all know what is that. Electronic force, we will cover more on that in static electricity. Light charges will repel, unlike charges will attract. Magnetic force is also similar. I believe you already know what is this all about. Unlike poles will attract, like poles will repel. And next we'll go on to vector diagrams. We have covered a little bit on the previous video. You can check them out in the top right hand corner over here. So what is this diagram all about? It's about being able to visualize how two forces are affecting an object, and we draw arrows to represent them. So the arrows have to be accurate to the direction and also to the magnitude. Remember, magnitude is the numerical value, and that is why we need to also pick a good scale that is able to fit your drawing onto the paper. So usually, maybe 1 cm is 1 Newton kind of thing. Oh yeah, and forces has a SI unit called Newton. So choose the scale, then draw the arrows in the right direction, and you can slowly add them up. In the previous video, it said that vectors can be moved around. You can join one arrow to another arrow, then you can see the resultant force, which is commonly drawn in double arrows. So if you are not familiar to draw a parallelogram, here is how you do it. So look at this example, choose a scale, then draw the two vectors of accurate directions and magnitude as well. Then you have to place, let's say for example you want to move the short arrow upwards, you have to place your ruler here, move your set square upwards, and then you match it up and ensure that the length remains the same. Then you can draw up the resultant force. Then you can measure the direction as well as the magnitude, which is the length. Don't forget to use the scale to calculate the right amount of newtons. So that is for vector diagram. For non-parallel vector diagram, parallel vector diagrams are a little bit easier. So if the arrows are in the same direction, then you just add them up or minus accordingly. Okay, so forces, what can forces do? Forces can do all of this. So if you play sports, these are quite simple. I won't touch so much into it. Now let's look at Newton's 3 laws of motion. 3 laws of motion is coined by Isaac Newton. You can read all about him. I won't cover about him. So the first law of balanced forces say that every object will continue at a state of rest or uniform motion in straight line unless a resultant force acts on it. So take this book for example. If it's at rest, the weight goes downwards, normal reaction goes upwards, everything's balanced, it stays in that spot, it does not move. Or if you are sliding it, the amount of force forward will match the frictional force backward, and it will travel in a straight line at constant velocity. It is also known as the law of inertia. This first law is where forces are balanced. However, what happens if forces are not balanced? This will lead us to Newton's second law. So if the forward force on the book is larger than the frictional force, the book will accelerate. You'll get faster and faster. It states that when a resultant force acts on an object of constant mass, the object will accelerate in the direction of resultant force. So the product of mass and acceleration of the object gives the resultant force. Therefore, it gives you this formula called F equals to ma. Then Newton's third law states that if the first object exerts a force on a second object, then the second object will exert an equal and opposite force on the first object. It's like when you kick off the wall of the swimming pool. When you swim, you kick the wall pushes you in front. When you start your race on the running blocks, you push the running block behind, the running block push you in front. You fire a firearm, the expansion of gases in the rifle will push the bullet in front as well as backwards to you. So in this third law, this is what we call action-reaction pairs. It's a very common vocabulary. For every action, there is an equal opposite reaction that act on mutually opposite bodies. Equal meaning equal in magnitude. Bat hit the ball of a certain force. Force of the ball on the bat will be the same amount of force but in different directions. Pushing the basketball upwards into the air is also an action-reaction pair. Hand push the ball push downwards into the hand. So it's good to really understand the three laws of motion. Rarely will people ask or questions ask you to recite them more. They will get you to apply them. Okay, so next we look at friction. Friction is a contact force that opposes or tends to oppose motion of between surfaces in contact. So we apply friction in walking, running, braking, but of course there is also a cost involved, wear and tear of shoes, and also car parts, braking pads. So how can friction be reduced? Friction can be reduced by these couple of methods. So it's pretty self-explanatory. Ball bearings help to prevent moving parts from rubbing against each other. Lubricants and polished surface help to create a smooth contact. Air cushion provides a layer of air to move around, prevents contact also. On the other side of the coin, friction can be enhanced by using these. Firstly, threads does not mean the thread used for sewing. It's the grooves you see on the tire, those are called threads. These help to catch the road better. Parachute increase air surface area to catch more air for air resistance and friction between the material and the air. Chalk is used to reduce moisture. Lastly, free body diagrams. Free body diagrams is a little bit like the vector diagram. It's about being able to identify the forces that are acting on a certain item. So these are the list of common forces that are acting on items in your everyday life. The weight always pointing downwards, normal always reacting against something that is on a surface. Air resistance is also acting on falling objects. Tension is always acting on hanging objects. For flying objects, there's weight, there's lift from the wings. T, thrust, the forward force that is acting on flying objects, and R for air resistance. And now let's go on to some questions. This may be a short chapter, but the questions that are asked can be pretty confusing. Okay, a block of wood is resting on a ramp. Draw the free body diagram using these three arrows. So it should look like this because normal always points perpendicularly upwards into the object. Weight goes down vertically, always vertical, and force opposes the motion. Okay, then a rocket of this mass, thrust of this Newton, gravitational field of this amount. Initial acceleration. So if you are not sure what is going on, it's always good to draw an image, a little sketch. The rocket has a weight downwards, so the weight equals to mg. This is the downward force, and the upward force is this amount, so the resultant will be this amount. Therefore, you can plonk in the formula F equals to ma, and bam, you will get the answer. Swimmer, this mass dives into a pool, decelerates at this after entering the water. Gravitational strength of this. What is the swimmer's weight and the resultant force? So weight is obviously 60 times 10, that will be 600 Newton. And resultant force for this one, that's all you can have because it's not much is given to you. Force equals ma will be this. Propeller on boat push backwards with a force of 2000 Newton. Boat moves through water. Resistive force is 1008. So the propeller generates 2000 newtons of force pushing the water. What is the forward force pushing the propeller by the water? So one object pushed 2000 newtons backwards. The water will be pushing the propeller 2000 newtons forward. Equal and opposite reaction, Newton's third law. The rest is all distraction. A person is pushing something. What are the forces? The force on the man's hands is to the left, and the force on the man's feet will be to the right. What is going on down here? If the person is pushing the object will push back onto the hands. If the person's feet is pushing on the ground, frictional force will push back into the person. Car has mass of this, driving force of this, acceleration of this. Resistive force will be, so the forward resultant force is this force equals ma 1006. So the resultant force is 2500 minus resistive force. Okay, this is quite interesting. Car traveling, only front wheels are driven by engine. So the engine turns the forward wheels, the friction experience will be pointing forward. And because the back wheels are being dragged, then they are being dragged backwards. The frictional force will come to the back. Okay, vector diagram. So same, stone supported by two strings. So what's the resultant force? You just need to draw your triangle or your parallelogram. Use two rulers and slide them along each other. You will get this value, and because it is a resultant upward force of this and the stone is stationary, it's not moving anywhere, so it has to be equal, just that it's pointing downwards. A person is climbing a wall. Draw the forces that are acting on this person. So quite interesting. This has to be on the rope itself, friction like that, normal like that. So lastly, talking about action-reaction pair, a book on a table. It is identical in these ways, it is different in these ways. Then the earth exerts a 10 Newton force. The other reaction pair will be this. And that is all for today. Hope you enjoyed this video. Do give it a like and subscribe, and share it with somebody who needs to see this. And I will catch you in the next video. Bye!